Alright, so in this video we're going to be taking a look at how do we graph our polar equations. So if we are starting with an equation that is just simply r equals 3, there is no theta in this problem, which means all we need to draw is a shape that has a radius of 3, and that is simply a circle. So you'd have 1, 2, 3 in each direction, and your circle would go through each of these points. And so that is all that your graph is going to be. Technically this is a circle, just ignore my freehand style here. Alright, so the next one we're going to be doing is bringing in the r, the radius, and the theta. In this first problem we have r is equal to sine of theta. And what we want to do is we want to find the coordinates and plot coordinates in terms of our radians and our radius here. So we want to start out, and you always want to start out with theta being 0, or an angle of 0. And so if you plug 0 in for theta, that gives you r is equal to the sine of 0, which is 0. And so we can start by putting a point right here on our graph. Okay. All right, so the next one is going to be, we're going to go in increments of pi over 2. And so sine of pi over 2 is equal to 1. And so if you rotate pi over 2 and then go out a radius of 1, that gives you the coordinate for this point. All right, so now we're going to go to pi. That's the next increment of pi over 2. And substituting in, sine of pi is 0. So that means if you rotate around here to pi, it says the radius is 0, well, that puts us back here at the origin. All right, so what happens is our graph is going to curve around to the first point and then curve around to the second point. So now if we continue this process, your next point would be 3 pi over 2. And the sine of 3 pi over 2 is -1. So if we think about our graphing here, 3 pi over 2, you would go this direction, and that would be this axis right here. Now, if it was a positive one, you would come out this direction. But we said it was a -1, which means we go this direction, and that's going to put us back at this point right here. All right, so we started our rotation going around this way, and then to this point, and then they'd go back around to this point. And if we go to 2 pi, that is going to put us back again at 0. So what we have for a graph is just simply going to be a circle where the diameter goes from 0, 0 to 0, 1. And that's pretty much it. All right, so now we're going to look at r cosine theta. And if we follow the similar type thing here and make a table of values starting at 0, now the cosine of 0 is 1. So at an angle of 0, that would put us at 1, which is right over here. All right, so now the next angle is going to be pi over 2. Cosine of pi over 2 is 0. So that puts us here. So we start out by going this direction to there. I'm sorry. Let me back that up. We started out over here, so we're coming this direction. Now your polar graphs are always going to be curves, and they're going to be curved going in a counterclockwise direction. So our first point was here, and the second point was here, so we go in a counterclockwise direction every time. All right, so the next coordinate here would be angle of pi. Cosine of pi is -1. And so once again, the rotation for pi would put us over here, but since our radius is a -1, that means we go this direction 1 unit. All right, so that's going to put us curving back to here. And we can continue with 2 more points, but what that's going to do is put us back at 0 and then back at 1 again. And so that's just going to draw 2 of the circles. So all we have to really draw is just 1 circle on the positive x-axis, going from 0, 0 to 1, 0. All right, so the next problem, what we want here is we want to find the sine of pi over 2 on this problem. That's the first angle that we want to find the sine of. Now, in order to find the sine of pi over 2, what we need for theta is going to be a pi over 4. And so this is kind of what you're going to do. Whenever you have a number multiplied by your theta here, take pi over 2 and divide it by this coefficient. That'll tell you the increments that we are going to be substituting in for theta. All right, so we have r and theta, and we're going to be building a table here, starting with pi over 4. Now, because we are going in increments of pi over 4, what we need is going to be this diagonal drawn at increments of pi over 4. So it gives us something that we can plot on. All right. So when the radius is pi, or theta is pi over 4, 2 times pi over 4 is pi over 2. The sine of pi over 2, oops, let me back up. I don't want to start with pi. I'll get to it in a second, but I want to start with 0. Still going to be sine of 0, which is 0. And then pi over 4. Now, 2 times pi over 4 is pi over 2. Sine of that is 1. And then the next increment would be pi over 2. Now, 2 times pi over 2 is pi. Sine of that is 0. And then the next increment is going to be 3 pi over 4. And for 2 times 3 pi over 4, that is going to be 3 pi over 2. And sine of 3 pi over 2 is going to be -1. Let's just go ahead and plot some of these points and get a picture of what our graph looks like. So we have 0, 0. Then we have pi over 4, 1. So the rotation for pi over 4 is right here. And the radius is 1. So I'm just going to put a point out here and call that unit 1. And so the rotation, the graph is going to go from here to here. And then the next point, it says the radius is the angle is pi over 2, so that would be this. But it says the radius is 0, so that's going to put us back here at the origin. All right, so our curve goes back to the origin here. The next point is going to be 3 pi over 4. 3 pi over 4, that's this line right here. And it says that the radius is -1, which means we go in the opposite direction. So we're going to go this direction 1 unit and put a point. So we're going to go from here, curve around to here. So we started here, curved around to here, back to 0, 0, and then around to here. All right, so Continuing with this, the next increment is going to be pi. Sine of 2 pi is 0. So our graph goes back again to 0. And we can continue with points, but this is what your graph is going to look like in the end. Okay. All right, so the next one is going to be very similar. Because we have a 2, we're going to be going in increments of pi over 4 once again. So we need these points, or these diagonals drawn on here. All right, so what I want you to do right now is just press pause and take a second to try to sketch out the graph just like we just finished doing. All right, so I finished making a table. This is just going up through pi. You really need to go up through 2 pi for this. But your graph is going to go through the points indicated on the graph here. So we're going to start at 1, 0. And the graph is going to rotate around this way, here, up, around, and then back up to this point, down, and back around to there. So that's what your graph would end up looking like. All right, so if we have 3 pi here, that means we're going to be going by increments of pi over 2 divided by 3, which is pi over 6. All right, so what we're going to need to do then is draw pi over 6, pi over 3, extend those lines, and I'll let you take a second to build a table starting at theta being 0 and then plug in increments of pi over 6. So go ahead and pause and take a second to go ahead and do that. Okay, so I went ahead and made a table utilizing points going up through pi. Now I only went through pi because when you start doing all the rest of the angles through 2 pi, the points actually end up plotting out to be the same points that are on the graph here, these 4 points. All right, so we're going to start out at 0, 0, and then we go to 1 pi over 6. So we're going to start here, go this way, and then we come back to 0. Then we go to -1, back to 0, out to here, and then back to 0 again. So that ends up being what this looks like. And then if we continued all the way through 2 pi, all we end up doing is just redrawing the same petals that we have here. All right, so go ahead and take a second and work through this one, doing the same process. And then after you unpause, then you can take a look at what this looks like. All right, so just like before with the other problem, I only went through pi because if you go through 2 pi, you just end up plotting the same points that are already on the graph over here, these 4 points. Now we're starting out at 1, 0, which is this coordinate right here, and then we're going to be rotating from here to pi over 6, 0, and then goes to pi over 3, -1, which is down here, back to 0, and then around to this other point, and then back to 0 again. All right, so this is kind of what your graph is going to look like. Once again, you're going to have 3 petals on this. Okay. All right, so let's take a look at the next problem. This time it's going to be r equals 2 sine theta. And as before, let's go ahead and pause. Go ahead and take a second, build a table, and try to graph this. All right, so if you'll notice, this is r is equal to 2 sine theta, which is very similar to the problem that we did at the very beginning, which was r equals sine theta. R equals sine theta was a circle with a radius or a diameter that went between 0, 0 and 0, 1. The only difference with this one is that you're going from 0, 0 to 0, 2 for your diameter. So your circle would look like this. Same shape, just a different radius or diameter if you want to look at it that way. All right, so the next problem, we have r is equal to 1 plus sine theta, starting at angle of 0, radius of 1, so that's going to start out here, and then it goes to pi over 2 to here, back to here, to the origin or the pole, and then back out to where we started. So curvature going in the counterclockwise direction, it's going to look like this, where it goes up, back to here, to the origin, and then back out to where we started. All right, and go ahead and take a second to work on this, and while you pause, I will create the table, and then we can look at it a little bit quicker. All right, welcome back. And this is going to be similar to the previous graph where we have 1 plus sine of theta, except this one is going to be starting out with an angle of 2 at an angle of 0 with a radius of 2. So we're starting out at this point, rotating around to pi over 2, 1, so to here, back to the origin, down to negative 1, and then back to where we started. So the graph is going to rotate around like this, going back to where we started. And that's the graph that we get for 1 plus cosine theta.